Good afternoon. Ladies and gentlemen, welcome to the Frontiers in Geophysics 2018 lecture. My name is Denis Didier Rousseau, and I am the chair of the AGU Fall Meeting Program. So welcome to this lecture. When you are studying the geological history of Earth, and as the centennial of AGU will show during all its celebration, we learn how dynamic our planet is, transforming itself through various cycles at various speed and with movements of diverse nature. Among those features, we know that the Earth experienced numerous glaciations which had strong impacts in shaping it. However, this natural variability has been described from the deep time to the present day. Among these glaciations, what is particularly fascinating to me as a paleoclimatologist are these records of the abrupt changes, especially those that are particularly well documented, which punctuated the last 130,000 years. Among those, the exceptionally massive iceberg discharge originated from the three main ice sheets covering the northern hemisphere and which invaded the northern Atlantic, resulting in severe changes to the climate. These iceberg armadas are particularly difficult to imagine as they correspond to a tremendous and unseen quantity of ice released in the ocean very rapidly. However, these phenomena remain natural features occurring within the natural variability of the Earth. Our planet is changing, but the main driver superimposed over natural variability is we humans. Indeed, the Earth is changing as the climate does, but this happens not only in some remote places far away from our own comfortable place. This is real and is at our door. To convince our fellow citizens confused by the active climate deniers, the best way is to show clear evidence, including photographs and film, that show that this unprecedented rapid change in the climate. We all have seen these pictures in textbooks and photos or paintings of glaciers showing how far they reached at the beginning of the 20th century and where they are nowadays. Also demonstrative, we don't get any sense of the tremendous dynamics which is behind. This is where our keynote speaker, James Balog, is making the difference. Jim, I cite Wikipedia, open quote, is an American photographer whose work explores the relationships between humans and nature. His work aims to combine insights from art and science to produce innovative, dynamic, and sometimes shocking interpretation of our changing world, end of quote. Jim Balog is testifying his way of this changing world through a very rigorous, impressive, and scientific approach. Extreme ice survey and trees are two examples of the technological innovations that James Balog developed to engage more accurately in favor of our planet and its future. To quote James Nachtwey from Time magazine, open quote, each new series by James Balog represents a quantum leap in creativity, which takes us deeper into the ultimate mystery of humanity's relationship to the natural world. He is a visionary, and his work are like sacred objects, close quote. I'm convinced that we will all leave this keynote with our minds filled with ideas, conviction, and moreover, indisputable images that this is real time to act as a scientist and citizens. Following this event from 2 to 3 p.m., I invite you to attend a lively discussion with Jim Balog and the host of AGU podcast South Pole from the sun in the Marriott Marquis across the street from the convention center. But before that, please join me in welcoming James Balog.
Well, thank you, and hello AGU, hello Washington. It's great to be here, and I appreciate all of you being in this room today. And I appreciate my friends at AGU who made this happen. This is a great opportunity. Now, I come to you as an eyewitness, a photographer, a filmmaker, an alpinist, and a scientist. My visuals are grounded in knowledge that's been collected by many thousands of curious and intelligent scientists and naturalists worldwide for centuries. This isn't something that I just made up by accident, right? This is grounded in your world. So what I do is an integration of visual art and science. And one of the great joys of my creative life has been that I've gotten to go and see a lot of different realities. And in order to do that, I've had to be something of a chameleon. I've had to wear different costumes so that I could function in different kinds of habitats and environments and to get the pictures I need to get. So I'd like to start this show with a quick little time lapse that shows you the metamorphosis of a photographer. Start out as a regular guy and then things get a little weird. There's a lot of climbing that goes on, wet weather, volcano weather. Then you have to do what needs to be done. And you wind up in your polar outfit at 30 below zero. Now, I've been asked to speak here about the frontier of geophysics. And as you all know far better than I do, there's many, many frontiers within the various disciplines of the science. But as far as I'm concerned, the most crucial one is not within the science. It's at the intersection, at the perimeter between science and the surrounding society. It's at the contact zone between what science knows and how the surrounding society is absorbing and assimilating and using that information. Now, science and art express two different aspects of human existence and experience. They're both vital, and one complements the other. Science is the rational, cerebral, often quantitative left brain experience. And the visual arts are the more intuitive, subjective right brain experience. In science, we seek to quantify, to collect the evidence, I should emphasize the evidence, collect the evidence and quantify it. In the visual arts, we seek to express and integrate that sensation into the creative work. So the integration of science and art gives a more complete and appropriate understanding of what's happening in the world than either paradigm can do on its own. So that's how I view my job, as a combination of art and science. Some of the images I'll be showing you today are excerpted from our new documentary film, The Human Element, which screens tomorrow night at the Smithsonian Natural History Museum, but more on that later. So let's get started with the pictures. Now, we're all familiar with the idea of nature's tectonics. They're the forces that build volcanoes and mountains and create lava. And they're the forces that crack the planet's crust with earthquakes and move continents around. These are natural tectonics. That's the overall catchword that I think surrounds all this idea. It's not just plate tectonics, there's natural tectonics happening. But I've come to realize that there's another force functioning in our world, and this is what I call it: human tectonics. Humans, whether we like it or not, are a force of nature. And they're a product Those human tectonics are a product of the size of our population, multiplied by our needs for survival, multiplied again by our desires for affluence, multiplied yet again by the power of our technology. And together, that equals human tectonics. Human tectonics, of course, shape the rest of the natural world. And that, of course, is what makes the Anthropocene, which we all know about, and which has been central to AGU's thinking and mission for so many years now. So the Anthropocene, as I see it, is a geologic epoch. It's a period of time. It's presumably a stratigraphy that will sit in the rocks for a very, very long time. But those Anthropocene consequences are a product of human tectonics. So they're two sides of the same coin, human tectonics and the Anthropocene. Now, in this show, I'd like to tie together how people change some of the primal elements during the Anthropocene. First of all, as we all know, we dig up Earth materials, right? And we drill them sometimes, of course. We dig them up and drill them, and then we burn them and throw the effluent into the air. That alters the air chemistry. And when you alter the air chemistry, of course, you wind up altering the hydrologic cycle. When you alter the movement of moisture around the world, one of the things that happens is you alter the wildfire regimes. So all these things fit together, and that's what I'd like to trace in this personal photographic journey through human tectonics in the Anthropocene. Okay, so starting with the Earth element. There's all this ancient buried plant and animal life. It's still decomposing, still making gases, making all sorts of substances and compounds underground. We dig down, bring it up to daylight. Among other things, we burn 5.3 billion tons of coal per year. This is a coal seam in Pennsylvania. Ironically, when we were looking for a shot of a coal seam in Pennsylvania, we could hardly find any visible coal seams. They're all way down deep, so these things are hidden from us. But here was one cut through in a railroad cut near a little village called Vintondale, Pennsylvania. Coal moving through Russia. Hampton, Virginia. And then, of course, there's oil. We burn roughly 34 billion barrels annually, plus or minus a little bit, depending on the energy in the economy, the financial energy, that is. Now, when a typical artist, scientist, environmentalist like me talks about oil and coal, you assume, don't you, that he's being critical of fossil fuels. And to some degree, I am, of course, as I think we all are, because we know what the adverse consequences are. But a full accounting of reality says something a little bit different. It says that we all of us currently depend on fossil fuels. These electrons pouring out of these lights up here likely are coming from power plants that are fed by natural gas or coal. I don't like that, but that's the way it is. So we have to acknowledge, painful as it can be sometimes, that we are in and of the tectonic impact of fossil fuels during the Anthropocene. It's woven into the fabric of our lives. Now, there's a big irony in having understood that and said it and accepted it. And it came when I accepted the ghost of my grandfather during the filming of The Human Element. He was a coal miner in western Pennsylvania, and he was killed when the roof of a mine collapsed 6 years before I was born. I never knew him, but his story looms large over my family, my father and my brothers. We've heard about it for all these years, well over half a century. But what I realized when I was up there shooting this segment for the film in western Pennsylvania is that my opportunity today, my opportunity to literally be standing here right now and to do everything else I've done for all these years is based on the foundation of his work and his sacrifice and his suffering as a miner. So I found that I needed to acknowledge and respect him, and by extension, on a personal human-to-human level, to respect the work of others like him that are still doing this kind of work today. Again, I may dislike the systems, I may dislike what history has dished out to us right now, but I have learned that I need to respect the people, the individuals. But the truth is that technology changes as we find a better way to go forward. The technology of my grandfather's time has become the junk pile of today. These mine cars are in western Pennsylvania, just down the valley from where he mined coal, and there's a good chance that he, with his shovel, had piled coal into these cars here. So our technology today is evolving, as it must, as all technology must, into something else. And in the particular moment in history that we find ourselves trapped in, we're evolving away from fossil fuels. Here's some more of that equipment that came from those mines. And I can't help but wonder, what will future archaeologists see in this pile of old mining equipment? Will this steel from these mine cars become a rock layer of the Anthropocene? Or will they become strange and indecipherable fossils trapped in sandstone? And somebody, who knows who, may be poking through rock layers 1 million or 2 or 5 from now and find the remains of all this stuff. So let's move on to air. This was a very impulsive picture that we did here. And what I did was I put my camera in a weather balloon. My friend Patrick Cullis in Boulder, Colorado, where I live. Patrick knew how to do this. He knew how to work with weather balloons. And look, I've always seen the pictures that the astronauts take looking down on the Earth, and you see that little layer of air, but those are the astronauts who get to do that, none of us. So I thought, you know, wouldn't it be cool if I could just put my little Nikon camera up in a balloon and float it up and see what happens? Well, what I discovered just blew my mind. It was 30 to 40 minutes, and we were at the edge of the breathable atmosphere. We were looking out into the blackness of space, looking down on this thin layer of blue air below, and I was getting the astronaut view. Half an hour, basically, and you're out of this. So when we look up, it seems infinite, but it isn't, obviously. And this was the first time that, because I had my own little surrogate eyes out there in space, acting directly on my behalf, that I understood how thin the membrane of air was and how precious is this membrane that we breathe. And I realized, you know, we're all citizens of the global air supply. And the human tectonic alteration of the air supply is a universal issue. It's a universal human issue. It never should have been politicized. It applies to everybody, regardless of their political or denominational persuasion. It touches all of us. Air is this tangible dimensional substance, but we can't see it. And I can't help but think that if we could see it, we'd be having a whole different conversation about climate change. We would accept and understand the reality of it. Look, as I look out into this room, I realize there's billions of molecules of air weighing down on everybody, 14.7 pounds per square inch right now at sea level, which is where we are. There's a lot of weight out there. There's a lot of volume. There's a lot of molecules, but we don't see it. We don't feel it. So right now, because we don't see and feel and touch the air particularly, we use it as a trash pit in our industrial processes. Yet we inhale 20,000 times a day. You don't even notice it, do you? You're sitting there inhaling all the time, 15 to 20 times a minute, 20,000 times a day. So what we put into the air out there, we're putting into ourselves in here, inside our chests. This is a little ironic Norman Rockwell-ish bit of Americana, bucolic western Pennsylvania farmland. It's a gorgeous state. I just love driving through the countryside. But of course, there's all these gigantic coal-fired power plants belching away right next to these beautiful farms. And right at the moment, we're releasing about 37 billion tons of carbon dioxide per year into the air, along with methane and nitric oxide and many other gases. Now here's another irony. I live, as I think I said already, in Boulder, Colorado, right at the foot of the Rockies. And for our own self-image in Boulder, as well as the way everybody else thinks about the Rockies around the country and around the world, you think of the air in the West as this beautiful, pure substance. And so I wanted to make a photographic record of what the air looks like. I know what the NOAA measurements say, but I wanted to see with my own camera eye what it looked like. And NOAA had an observation tower out in the plains about 10 miles east of the Rockies since the mid-1970s. And so we put a time-lapse camera 1,000 feet up in this tower and let it shoot for 2 years. This picture shows what the view looking northeast was on a perfect day. That's what you expect the Rockies to look like. But the visual evidence shows that many of the days are not so perfect. And it's because of tailpipe emissions, power plant emissions, wildfire smoke, and fugitive emissions that come from the oil and gas field that's being drilled right out here by this tower. Another day. And you look out there and you hear on the news, okay, there's a big fire up in, there's a big fire in Alberta. We get the smoke 1,500 miles south. There's a big fire in the Canadian Arctic. We get the smoke 2,000 miles south. There's a big fire in California. We get it 1,000 miles east, and on and on and on. This stuff funnels across the country. We breathe a lot of it. You all breathe a lot of it. And by the time it gets to the East Coast here, the fire smoke, the fugitive emissions, you may not see it very clearly, but it's still in the air. It doesn't go away. But I had another epiphany while we were working with these cameras. I'm standing up there and we're bolting the camera to the framework of the tower, and I'm looking out and I started to realize, my God, all over the place. There's drill rigs, there's pump jacks, there's wellheads. This is all within the first mile or two where I can see it. And they're all extracting oil and gas from the Niobrara Shale. It was all around me. And so then I thought, I need to learn a little bit more about this extraction field around me. That tower is down there on the bottom left corner of the white perimeter of Weld County. And as you can see, there's 23,000 plus active wells right now, plus several more, like 500,000, no, not 500,000, 50,000 that are not active further to the east. And whatever's coming up out of these things is being breathed by roughly 4.8 million people in the Front Range urban corridor. Now, the vast majority of wells are well sealed, but there's a fraction of them, the new wells even, that leak, roughly 5%. But many more leak as the gear ages. There was a Cornell study that was done in California, what's wrong with me here? Done in Pennsylvania, and they found that roughly 40% of the wells eventually leak to either the air or the water or both. And that is kind of one of the byproducts of this wonderful natural gas boom that we're living in right now. So as you can see, 1.3 million production sites all around the country shown in these yellow areas. But these fugitive emissions are blowing all over the place, and we all get the consequences of them. Here's another form of visual evidence. This little group of pictures is shot at a place in Denver called the Morgridge Academy. And it's a school within National Jewish Hospital in Denver. It's there strictly for children who have asthma that's so acute they can't attend regular schools. They need medicine way too often. Their moms and dads give them medicine in the morning a couple times before they go to school. Then they go to school, and these specially trained nurses in the infirmary in school administer asthma medication 3 to 5 times a day during the school day, and then the kids go home and they get zapped with the medication again so that they can survive. This is a young man in 7th grade named Jamir. Just wonderful children. Here's another one, 7-year-old, Josiah. childhood asthma rates in the United States are 1 in 13. And it's because air pollution is bad for asthma. These extra loads from all the extra particulates coming off the wildfires, which we'll see more about here in a minute, the fugitive emissions, all of it, it's bad for asthma. And these kids, a lot more kids and elderly people wind up in the emergency rooms of the Western United States during the summer fire season, when the big fires are going off. And that used to be in the Front Range of Colorado. It was rare when you saw the sky go from blue to brown because something blew in, some brown smoke blew in from a fire far, far away. 20 years ago, you would notice that happen maybe once a summer. Now, we have brown air most of the time from early June until either early September or into the middle of September. The fire smoke is much more ubiquitous than it used to be. And then this 11-year-old girl, Marilyn, and she can recite for you her litany of woes. She's been to the ICU twice. She's taken an ambulance to the ER 4 times when her asthma attacks were bad. And we interviewed her and we asked her, what's asthma really like? Because I haven't had asthma. You know, I've had some hay fever now and again, and I know I sneeze a lot, my eyes water. I said, what's asthma like? Well, she said, quote unquote, it's like someone is holding you underwater and you can't come up. So on to water. We have a changing relationship with water. And we understand, it's obvious, that when you warm the atmosphere, it converts solid ice to liquid. And when you have more water, it eventually dumps the water that melts from land-based ice into the ocean. So we're up on the Greenland ice sheet here. Everyone understands, you warm the air, you melt the ice. And this has been going on for years, but it's going on at a much intensified rate from what once happened. A new study that was just published last week found that there's more melt right now than at any time in the last 350 years. Probably more melt than has happened in the last 5,000 years. And there has been a demonstrable, huge increase in melt in Greenland since the mid-1800s, when the Industrial Revolution really started to morph the atmosphere. Of course, it flows through channels down into crevasses and out to the sea. If you look hard up there on that little ice nose on the right, you can see my assistant Adam to give you a sense of scale. And glaciers, of course, break off icebergs directly into the ocean when the ice actually touches the sea. And as so many of you know, that's called calving. If you take the combination of melting and calving, whether it's in Greenland or the small ice caps or the glaciers or Antarctica, you add all that together, we're putting roughly 500 billion tons of ice into the ocean every year. It's turning into water. 500 billion tons of ice are turning into water. So in part, in recognition of that fact, I started this project that Denis Didier mentioned, called the Extreme Ice Survey. I started this project in 2007. I had photographed a National Geographic assignment in 2006 on ice, and I realized that there was a lot to do here, and that there was an historical transition of the natural landscape happening right in front of me, and I wanted to make a documentary record of it. This project eventually became featured in the film called Chasing Ice, which I know many of you have seen. In addition to the folks who are up here on the screen, I'd like to shout out a few other people, some of whom are in this room, and all of whom are actually members of AGU. Other people who have worked in one way or another on this team. Ethan Welty, Marco Tedesco, Walid Abdullati, Martin Trufer, Mark Fonstock, Eric Rignot, and as well the late Alberto Bahar. In addition to those folk from the AGU community, my friends at National Geographic, Rebecca Martin, John Francis, Dennis Dimmick. And in addition to those folks, my dear daughter Simone, who is working on natural hazards in her professional life now, and I've had the pleasure of having her with me on some of the field work. So in the beginning, we put out 25 time-lapse cameras, bolted them to bedrock right alongside these glaciers that were dumping ice into the ocean. Eventually, we wound up with a network of as many as 43 cameras. We don't have that many out right now. I think it's about 15 or 18 cameras. But at its peak, the Extreme Ice Survey had cameras in Alaska, Greenland, Iceland, Canada, Austria, Nepal, and on the Antarctic Peninsula. When we started this whole escapade in 2007, I expected we'd do about three field seasons. That's all my brain could imagine. It's all my brain could imagine possibly raising the funding to do. And here we are 12 field seasons later. I never imagined we'd still be doing this many years down the road, but the record that we're collecting is so striking and such an historical monument, we're still going. At this point, we have roughly 1.5 million pictures. It's a big archive that may wind up at the National Snow and Ice Data Center, as well as some other university destinations before too many more years have gone by. The cameras are Nikons that are put in these little Pelican housings that we custom modify, and we collect solar energy, pump it through batteries, and it makes the cameras work. And we have to go out and capture the pictures every so often. Here's one of the cameras bolted to a cliff at 19,000 feet up there. The camera's up there in the box on the top right. There's a glacier down in the bottom called the Khumbu, and there's a big mountain up on the left called Mount Everest. So let me show you a time lapse. This is the camera clicking away every hour or half hour around the clock, as long as it's daylight, and then we go through the sequence to get light that matches, basically overcast light, so your eye isn't bedeviled by too much flickering, and we assemble that into a time series. This is a glacier in Iceland. I'll try and pronounce it in my terrible Icelandic. It's called Sulamijíkit, and this is a 12-year time lapse. I've seen it 1,000 times, and every time I see it, the change still blows me away. Here goes. One of the things that always stuns me is that we watch lakes and rivers forming in the course of this project. That was something that never occurred to me when we started this. Now, in the real world, you can't turn time backwards, can you? You're stuck with time as it is. But fortunately, through the magic of photography, we can turn time backwards. And so we put Humpty Dumpty back together again. And this is where the ice started in 2007. And this is what it became. Now let's look at some repeat pairs. This is where I'm essentially going back and just trying to snap a frame that's in the same position where I did it some years ago. We're up in Canada now, in the British Columbia Coast Mountains, where it's as if a giant hand has come in and is just peeling ice off those granite ridges and deglaciating the landscape at a tremendous rate. The Bridge Glacier. Another one, the Tahuming Glacier in Canada. One of my favorite subjects in grad school studying glacial geology with John Andrews was the alpine landscape and how this morphology that we see out there in our beautiful mountains, how that's formed. And you hear about tarns, glacial tarns, these little lakes that are formed around these cliffs and in these alpine valleys. It never occurred to me 40 years ago that I'd actually watch an alpine tarn being formed in the course of a very few years through the photographs, but there's an alpine tarn in this basin. Switzerland, the Trift Glacier. And back to a time lapse. This is Mendenhall Glacier in southeast Alaska. So that's where it began. And this is what it's becoming. Without the memory of that camera, that landscape is gone. It may never be seen again in the history of civilization, but the pictures preserve it. That's when I really understood the power of photography, that preservation of memory. So every single block of ice that comes off the land puts water in the ocean sooner or later. So more melting and calving makes more water in the ocean. And now we go on to questions of the ocean. This is at Hurricane Matthew in 2016 in Charleston, South Carolina. So many of us are familiar with questions of sea level rise, but I'd like to cast the story in bigger terms. There's actually a boundary adjustment going on right now, right under our noses, between the ocean and civilization and what's happening on the land. First of all, okay, there's vertical rising of the seas, roughly 3.5, 4 millimeters per year on average around the world, approximately 1/8 of an inch. And as we all know, that additional water acts as a battering ram when storms like hurricanes and nor'easters come slamming into the lands. There's just more volume there to pound away at the land. But there's a horizontal thing happening at the same time. And I had to work on 3 hurricanes in the southeast in the past few years before it finally got through my head that what I was seeing was a shifting boundary between the sea and civilization. Right down the middle of this picture is a seawall, and the ocean is supposed to be about 8 feet down below that seawall, but as you can see, the ocean, for at least a short time, for the moment, has reclaimed a piece of land. It's gone over the seawall and created a new reality. Hurricane Matthew in Charleston, South Carolina. It's the same water you saw in the previous picture, and this is further inland, about 1/2 mile. Because the other thing that's happening too is you have the vertical change in the water, you have the horizontal change in the water, and during the big storms, guess what? There's a lot of water, trillions of gallons that are getting dumped out of the sky. So all of these things together are changing the terms of engagement between people and water. Hurricane Katrina in 2005 on the Gulf Coast of Mississippi, 28-foot storm surge, which is about as high as where those arches meet those sidewalls, maybe a little bit higher. Imagine a wave being driven in by a storm off the Gulf of Mexico, slamming into these houses. Hurricane Irma in 2017 in St. Augustine, Florida. NOAA has estimated that 3 hurricanes in 2017 cost the US economy $265 billion. $265 billion in 1 year. So as part of this horizontal and vertical boundary adjustment, there's yet one other factor. There's something called king tides, K-I-N-G tides. And they happen typically in September, October, and November, and it's when the Earth and the Moon are in a different alignment where the tidal forces are more intense. And one of the places that's most acutely affected by king tides is Norfolk, Virginia. And as you can see in the background, there's some lovely houses in a nice neighborhood along the shore of Chesapeake Bay. And 11 o'clock in the morning, here's what happens. The tide comes up and takes over the city streets. This goes on for about 5 or 6 days, and then the tide settles back to where it's supposed to go. Now imagine a hurricane coming in at the same time as this situation is happening. Same kind of syndrome here on Tangier Island, which is out in Chesapeake Bay, Virginia. This area, Tangier, Norfolk, Virginia Beach, which is quite a lot of people living in very well-developed, very pleasant communities, it's being subjected to a combination of land subsidence because of tectonic forces and sea level rise. And the total of those two things is giving a boundary adjustment vertically of about 1.5 feet in the past 100 years. On Tangier, there are roughly 700 people living there in a perfectly nice, cozy little community of fishermen and oystermen and crabbers. 700 people, and the U.S. Army Corps of Engineers estimates that it will cost about $100 million to protect that community, to ring it in stone and protect it from the rising seas. And if they don't, the island will be gone in somewhere between 20 and 50 years. One of the local moms has this very poignant quote in our film. She says, "We're one storm away from becoming a part of history." So the world is changing. The world is changing. It's not an abstraction for the future, it's right now. And our friends in various highly influential buildings down the street can't seem to get that through their heads. The coastline that today's children will know when they grow up will be a profoundly different place from the coastlines that we know today. So I made these symbolic pictures, and I feel the eyes of the children watching us. They're reaching out from the present, and in some kind of weird, poetic way, maybe they're reaching back to us from the future, and they're asking, did you do enough? Did we do enough? And I, at least, want to be able to say, yes, I did everything I could. So on to fires. Anybody who's ever lit a campfire knows that when fuels are more dry, it's easier to get the fuel on fire, right? So if you dry out the climate, the way so much of the western United States and to sometimes the southeastern United States is getting dried out, if you dry out the climate, you dry out the fuels, and it makes it more fire prone. I found fires to be incredibly fascinating to work with. Flames are fabulously beautiful. Anybody who's ever sat staring into a campfire or a fireplace and you watch those flickering flames, you know it's just fabulous stuff. But at the same time, these big fires are awful in their violence and their intensity, and they're consuming the landscape. The science is amazing. It's really, really fascinating because it integrates a lot of different things. It integrates biology in the sense of all the different types of fuels make a big difference in how a fire behaves. It integrates questions of the terrain. The shape of the land drives a lot of fire behavior. The weather, the climate, and then of course there's human technology and human behavior that affects how the fires propagate or don't, or get stopped or don't. So fires are sort of the ultimate expression of human tectonics. And one of the big ways that they're an expression of human tectonics is that we people like to live in forested areas because we like to get out of cities and suburbia, live where there's more trees, so we move into these flammable landscapes. And in addition, we try and suppress fires because we think that they're all negative and destructive and we don't like fires around us. And so the fuels build up, and when the big fires come, which they always do, there's more fuel around to go ripping through the landscape. The evidence of how many more fires and how much bigger the fires are has been very well understood, very, very well measured. It's not computer models, it's not imaginary, it's been counted for 50 years, and people understand well what's gone on. And there's a very clear correlation between big fires and warming temperatures. It's not exactly precise, but you can see the trends. The temperature is the yellow line, the number of large fires is the red line. Our team spent 3 seasons photographing and filming wildfires. We all got trained and certified as wildland firefighters. because we wanted to know how to function out there. We wanted to know what we were looking for, what we were looking at, and most importantly, how to be safe, because it's kind of a crazy, out of control environment a lot of times. I find the flames sometimes as beautiful as stained glass in a Gothic cathedral. It's fantastic stuff. Yet it's horrific. The firefighters are heroes to me. They do hard, brutal work in tough conditions. The radiant heat is almost impossible to comprehend. You know, I had been by good-sized bonfires, but what you don't appreciate is how much more radiant heat there is when the wall of flame is 10 feet or 20 feet or 100 feet. I mean, literally, it just feels like your skin is melting off. Just before I shot this picture, I had been about 5 feet closer to the fire, a little past where this guy was, and I had no shroud on my face. And truly, it felt so searing there for one block of a few seconds as I was trying to shoot. It literally felt like the skin was about to drip off my face, and I ran away from the flames. The other thing that happens is, of course, you get a lot of carbon particles in your lungs. And the long-term studies of firefighters show that these guys who have spent decades on the fire lines, when they're old people, they have essentially black lung disease the way coal miners do, from all the particles that are in their lungs and never go away. At the same time, and I hadn't realized this, when you burn trees and grass, it releases all sorts of toxic compounds like formaldehyde, benzene, and a whole long list of other things. And those chemicals soak into your blood and organs. And this is me at the end of a really bad day in California. These fires along the Central Valley, in Napa and Sonoma and in the foothills of the Sierra, they're typically happening on days where the air temperatures at 1 or 2 in the afternoon are 100 to 105 degrees. And the ground's temperatures on a southwest-facing slope are running 135, sometimes even 140. So through your boots, it feels like you're walking on a fry pan. And you're wearing Nomex, this fabric that keeps the embers out if the embers from the fires fall on you, which is great. But at the same time, that heat-resistant fabric traps heat inside the shirts and the pants. So you're like in your own self-contained thermos bottle, and you're boiling inside there. I've had many days on fires where I've consumed 4, 5, 6 liters of water in a day, and I'm still thirsty by the end of the day. Your body just takes all this in, and all the vapor goes out through your breath and through your sweat. More evidence. Lots of acreage burned in the past 40 years as a consequence of climate change. So here's some history that'll really floor you. We got this from some friends at a research group at UC San Diego. They were very kind to supply this to us. Los Angeles. Los Angeles is a human tectonic city, an island of concrete, steel, and asphalt surrounded by intensely flammable mountains. They burn, the plants grow again, then they burn again, and the cycle just keeps on going, surrounded by fires. The civilized area is surrounded by fires, and of course there's lots and lots and lots of houses and towns in these areas that burn over and over again, and thus the problems. Northern California, San Francisco is just off the lower edge of this map. 2018 was a terrible year for California fire history. The largest fire in California history was the Mendocino Fire, 459,000 acres. The deadliest fire was the Camp Fire, up there in the top right. 85 people dead, 11 are still missing as of today. 153,000 acres burned. That's the fire we all heard about in the latter part of November. On the 16th of Brownness Fire, this bulldozer operator, Robert Reagan, was up cutting a fire break around a house to save it, and he started back down the canyon, and the road collapsed underneath him. The bulldozer tumbled down, and he was killed in the course of that. And his firefighting crew put up this memorial to him where the bulldozer tumbled. And we worked on this fire for a couple weeks. Here's another marker from that fire, a filing cabinet. To me, this is maybe, even though it's just a blob of metal, I find this really a poignant image in the sense that a filing cabinet is a totem of human order. It's where we try and put our precious things in there, and we keep it in a linear arrangement that kind of organizes our lives and our minds. And so the whole house burned down around this thing, and there's the filing cabinet left behind. And this juxtaposition of order and chaos really floored me. I have no idea, by the way, if his precious papers survived as well. The 4 Mile Canyon fire in the foothills of the Rockies. This was actually just west of my own house. And our house was lucky to escape the Holocaust, but my neighbor's house wasn't. So these firefighters, to me, as I said already, they're heroes. They're diligent, determined. They do hard, brutal work under horrible conditions. They deserve to get paid 10 times what they get paid. 19-year-old firefighter Kerrigan. She says her favorite exercise is weightlifting. Strike team leader Tony Howard from Mendocino County. So to close the main pictorial part of the show, I'd like to share a trailer with you from our film, The Human Element. It will screen tomorrow night at the Smithsonian Natural History Museum. Its official release will be online on January 29th on iTunes. And it will be on other channels that are still being determined right now in addition. We're giving it away pro bono for public education. At whatever level somebody can use it in the educational system, we're happy to make it available. But we're expressly and specifically working particularly with the National Science Teachers Association, and we will have a big campaign at their annual meeting in April to give the film away along with the study guide so that teachers can use all the film or pieces of the film in the different elements to engage their classes with. So here goes, and then I'll come back with a couple of closing thoughts.
The state of California is resorting to drastic measures to
the most severe conditions.
When I became a photographer, I wanted to celebrate the elegance and beauty of nature. But I soon realized there was a more complex story going on in the world.
Very powerful force of Mother Nature.
About the collision between people and nature. And I felt a great sense of urgency to bear witness to that. We need to get out of here because the water is rising around us.
As you can see, the water's just tearing it to pieces.
Front Range is still under an ozone action alert.
The majority of our kids are struggling with air.
In the United States, we have a fire problem.
The fire was huge and spread really fast.
These are wildfires we have no control over.
Little tornado right there. We depend on the stability of the fundamental forces of the world. Earth.
When you work in the mine, coal becomes part of you.
Air.
You're most definitely afraid of the air that you're breathing in.
Water.
Water and the folks on Tangier, we're joined, we're connected.
Fire.
Just respect it and maybe live a little longer.
And the fifth element, people. An imbalance in one element leads to an imbalance in another. People are the only elements that can choose to restore balance.
Good things come to people who hustle.
And that gives me hope.
We need the help and we need it pretty quick.
We're one storm away from becoming a part of history.
Our deeds are leaving their imprint in the fabric of time. And what I want to do is bring this story to life. Okay, in closing, I'd like to touch on a few things that are not normally discussed at science meetings. Yet I think they're integral to understanding the contact zone where the physical world of our science encounters the human mind and spirit. Human civilization needs a new vision of itself. Look, for thousands of years, Western civilization has behaved as if people are separate from nature. Nature is somewhere over there, and we humans are something else over here. But the very concepts of the Anthropocene and human tectonics overturn all that. We are in and of nature, not separate from it. When we change the rest of nature, it changes us in return. So I consider that the reality of the Anthropocene and human tectonics is the bedrock concept on which we must stand in order to support a more viable future. Because if people realize that when we damage the rest of nature, it can damage humanity too, we'll be far more inclined to do the right thing. We in this room need to use our vision to inform new choices. Science and art may reveal the issues, but heart and soul must resolve them. And that's what has to happen out beyond this room and beyond my own work, obviously. Because underneath the physical evidence and the creative evidence are profound moral, ethical, and philosophical issues of human choice. Are we a greedy people who would consume everything for themselves and leave nothing for others in the future? Are we indifferent to the eyes of the children as they look back at us, appalled at the firestorm we've made? I will confess that some days it's hard to give optimistic answers, but I still believe we're bigger and better than that. Since the human element is the only element that can choose to restore balance in this world, make your choices be the right choices. We who are gathered here today need to keep using our voices. Let's look with eyes wide open at what's happening all around us. And I won't pretend that things are great. We all know that we live in a horribly noisy political and social environment. It's choked with lies, deception, propaganda, bizarre ideology, and abject, willful stupidity. There's no simpler way to put it. But remember, these kinds of issues have corrupted human governance since the dawn of creation. It comes with the human race. So we have to grow a thick skin and learn to ignore these kinds of problems. Because I can't promise you that the truth of reasonable, rational, scientific evidence will be embraced, nor that the pushback won't make you frustrated, furious, or exhausted. I will confess that personally, I struggle every single day to stay energized in the face of the craziness. I need to remind myself over and over again that nothing consequential has ever been accomplished without facing adversity. I need to remind myself that all this work is in service to something much greater than we are, and don't forget that. And that something is our eternal ally, the earth itself, whose voice speaks in the air, the water, the ice, the forests, and the fires. A voice that a solid majority of the human race is acknowledging. People hear it, and they're acknowledging these changes. So I, personally, make a willful choice to keep pushing forward with my work in spite of the frustration. Many of you have been doing that too. Keep on doing it. State the facts and the evidence. Don't despair. Hold your heads high. Stay strong, because guess what? The world needs you. The world needs everything that's happening inside this building right now. A final point. A few blocks from here, there's a sacred document. It's called America's Declaration of Independence. In it, some wise people wrote down the idea that we have an inalienable right to life, liberty, and the pursuit of happiness. But way back in 1776, when they wrote that declaration, who could have known what issues would impinge on our lives in the 21st century? So in recognition of the profound obligation we have to our own time, to our children, and to all the souls who will someday inhabit this planet, I would like to suggest that we declare another principle too, because life, liberty, and the pursuit of happiness don't magically just descend on us from the ether. They must be grounded in the physical reality of a healthy and sustainable world. So I would add this: we the people have an inalienable right to clean air, clean water, a stable climate, and the pursuit of truth. And that, my friends, gives eternal purpose to our work right here on the frontier of science and art. Thank you. Okay. Okay.
We are running out of time. Okay, thank you very much, Jim. I'm sorry we are running out of time, so we will not take questions. Thank you very much for joining us.